Here's problem 22.5. A lawnmower has a 6 horsepower engine. 1 horsepower is equal to 750 watts, joules per second. If the engine has an efficiency of 20% and the throttle is such that the engine cycles 10 times a second, the heat that is expelled in one cycle is... So, we're given our power. It's a 6 horsepower engine, and we know that there is 750 watts per horsepower. So that's going to give us a power of 4,500 watts. Okay. We know by definition power is equal to work per time. So work will equal power times time. And we're also told that the frequency is equal to 10 times per second, 10 cycles per second. So the time we're dealing with here, the period of time for one cycle, is 1 over the frequency, which would be 1 over 10 per second, or 1/10 of a second. Hence, the work will equal the power times time, 4,500 joules per second, times 1/10 of a second, and that'll give us 450 joules. So the work performed is 450 joules. Okay. We're also told that the efficiency, which is what we gain over what we give, and for an engine like this, what we gain is the work done, and what we give is the heat exchanged from the hot reservoir. So the heat exchanged from the hot reservoir is going to equal the efficiency, or the work divided by the efficiency. So that's going to be 450 joules divided by 20%, or 0.2. And what is that? 2,250 joules. We want to find the heat expelled in one cycle, so we want to find the heat exchange with the cold reservoir. By definition, the work is equal to the heat exchange with the hot reservoir minus the magnitude of the heat exchange with the cold reservoir. So the magnitude of the heat exchange with the cold reservoir is going to equal the heat exchange with the hot reservoir minus the work. That's going to equal 2250 minus 450, or 1,800 joules. So the heat expelled to the cold reservoir in one cycle of this engine is 1,800 joules. Note that we could have gotten this somewhat more directly if we say that the heat exchange to the cold reservoir is equal to 1 minus the efficiency over the efficiency times the work. And that would be equal to 1 minus 0.2 divided by 0.2 times the work, which was 450. And 1 minus 0.2 would be 0.8 divided by 0.2 would be 4. 4 times 450 will give us 1,800 joules. So that would be another way to come up with the heat expelled to the cold reservoir, 1,800 joules.